Right. So from 16 to 13. So anyway, so to the others who are not here yet, so we'll just catch up to us. Anyway, so do you guys have a question regarding with this one?
None, sir.
Wala po.
Answer.
Answer.
All right. Okay, so let's now continue to the next one. So we have here another example for a reflexive relation. So is this an example of reflexive relation? Yes or no?
Yes, sir.
Who's saying that this one is a reflexive relation?
Sir.
How about the others? Who's saying that
Sir.
this one is not a reflexive relation? Not a reflexive. Anyone?
No, sir.
Yes? Ano yan? So Miss Maxine, what is your answer?
No po.
No. Okay. So isang yes, isang no. Okay. So the correct answer is no. Okay. So this one is not a reflexive relation. Okay. So again, when I say reflexive relation, so all of the elements that is listed should have its own reflection or its own reflexive order. Like in here, we have AA, yes, but for BB and then CC, we don't have that one. Okay, what we have is BC and then CB. Okay, this one is actually an example of symmetric. Okay, so yes, we have BB, but then again, the BB and then CC is not here. So example number 2 is not a reflexive relation. Right? So are we clear on that?
Yes, sir.
Yes, sir.
Sir.
All right. Okay, so let's move on. So here's the diagram of a reflexive relation. So as you can see, we have 4 elements, 1, 2, 3, 4, and then all of them has its own reflection. Okay, 1, 1, 2, 2, 3, 3, and then 4, 4. So same with this one, we have 2 elements, we have AA and then B. All right, so let's move on to the symmetric relation. So this one is also super simple. So for all xy is the element of x such that xy is an element of R, then yx is also an element of R for us to be able to say that this one is in a symmetric relation. So let's have this example. So let R is equal to AA, BC, CB, and then DB. So as you can see, it says here this one is symmetric. Okay, why? Because as you can see right here, if we have xy, we also have yx. So actually, if you're going to apply the reflexive, or I mean the symmetric relation on the reflexive properties, so that's already asymmetric relation. Okay, so symmetric hindi asymmetric. Okay? Kasi meron lang other. It's asymmetric. It's asymmetric. It is a symmetric relation. Okay, so as you can see right here, AA is still the same with AA, but in here we have BC, then we should have CB, which is we have. So no problem with DB since it's the same concept with our reflexive relation. So this example number 1 is symmetric relation. All right. And then if you're going to take a look on this one, example number 2, this one is not symmetric. Why? Because if you're going to take a look on this one, 1, 2, so we should also have 2, 1. But if you're going to find 2, 1 in this set, this cannot be found. So this one is not symmetric anymore. Okay, so all you need to do is find one ordered pair that is not symmetric, then that one is already not symmetric or uh, asymmetric, okay, or anti-symmetric, right? So are we clear so far regarding with symmetric?
Sir, question, sir.
Yes?
Sir, is a reflexive relation, sir, still considered symmetric?
Yes. It is symmetric relation. Uh, if it's only like this, 1, 1, 2, 2, 3, 3, and then 4, 4. But if it's like this, wherein this one is a reflexive relation, okay. But if you're going to take a look on the other ordered pairs wherein we have 1, 2, but it doesn't have 2, 1, then this one is not symmetric relation anymore. All right. So what I'm talking about when I say reflexive relation is just that ordered pair. So one ordered pair only. Okay. Just like this one. So reflexive order, one single order, and then another uh, ordered pair. Okay. So those two only. Okay, not the entire. Of course, this one is not reflexive, but this one is symmetric. All right. Did I answer your question, Mr. Lipson?
Yes, sir. Yes, sir.
All right. So any other concern or clarification?
Wala po.
All right. So kung inaantok kayo guys kape-kape muna kayo dyan. All right. So let's now move on to the next one. So here's the diagram representation of asymmetric relation. So again, if we have V going to the W, we also have W going to V. So it should go back to the another ordered pair. So as you can see right here, we have the AA, and then we have the DD. We're in, no problem. But in here we have the BC, so we should also have the CB, right? And then for this next example, okay, we have the this set. So 1, 1, 1, 2, 1, 3, 1, 4. So this is the past example, example number 2. So of course, this one is not symmetric, as I have mentioned a while ago, since if we have 2, 1, we should also have, I'm sorry, if we have 2, 3, we should also have 3, 2. Okay, we have 1, 2, we should also have 2, 1. Wherein we don't have that in this diagram, right? So this one is not symmetric relation. All right. So are we clear so far? Going to be the diagram of symmetric relation.
Yes,
Yes,
sir.
sir.
All right. So next one here is of course the antisymmetric. So as I mentioned a while ago, if that one is not asymmetric, it will fall on the antisymmetric properties already. Okay. So just like this one. So we have 1, 2, but 2, 1 is nowhere to be found. So this one is antisymmetric. So the same with this one. We have BC. Oops. Sorry. This one is actually symmetric, wherein it's just not anti-symmetric. Okay? So not is symmetric. Okay? So this one is symmetric, okay? Or not anti-symmetric. Okay? So we have BC. We also have CB. All right. So clear regarding with anti-symmetric?
Yes, sir.
Clear po.
All right, so let's have another example. Is letter A anti-symmetric or no?
No.
Yeah, so the correct answer is no. Why? Because again, when we see anti-symmetric, we are asking for an element. So if we have xy, then we should not have yx. Wherein in here, it doesn't have an x or it doesn't have a y. So this one is not anti-symmetric. Okay, how about letter B?
No, sir.
This one is not, ang gulo kasi, nagugulan ako. Sasabihin ko na sana symmetric. So this one is symmetric, okay, or not anti-symmetric. Okay. How about letter C?
Anti-symmetric, sir.
This one is anti-symmetric because we have 1, 2, but we don't have 2, 1. All right. So let's now move on to the transitive relation. So this one needs 3 ordered pair in total for us to be able to say that this one is really transitive or no. All right, so again, we have x, y as your element of your relation, and then if you also have y, z as your element of your relation, then we should also have x, z as your another ordered pair in that relation. Okay, so again, this one is similar with the hypothetical syllogism on the inferencing. So we have this example. So as you can see, we have 1, 1, and then 1, 2. So from here, we already have the condition x, y, and then y, z, right? Hello, guys?
Yeah, yes, sir. Correct, sir.
Yes, sir.
All right. So again, we have here the x, y as your first ordered pair, and then we have x, y, y, z as your second ordered pair. So if we have this two ordered pairs wherein it is meeting the condition of the transitive, then we should have the third ordered pair x, z. So from here, we have the 1, 1, and then 1, 2. So 1, 1, 1, 2. So as you can see, your y is the same. Okay, oops. Y is the same. So if they are the same, then you should have another ordered pair x, z, or 1, 2. Okay. So the question here is, can we find this ordered pair on this set?
Yes, sir.
Okay.
Yes,
Which is
sir.
fine. All right. So very good. So just do it on every ordered pair. Okay. So we have 1, 1. We should have 1, 1, and 1, 2. Then we should have 1, 2, which is this one already. What else? We have 1, 1, and 1, 3. Okay. Forming the same y's. Then we should have 1, 3. Okay. Which is this one already. Okay. What about 1, 1, and 1, 4? So again, they have the same y's. Then we should have xc, which is 1, 4, which is again this one already. Okay, so it just happened that it it is already in there. Okay, on the example of yz. Okay, so it is filling up the condition of the x z. Okay, so how about this 1, 2, and then 2, 2? So as you can see, we have the same uh, y's, then we should have 1, 2. So where is that 1, 2? This one. All right. So as you can see, all of this, if you're going to check uh, each one of them, so they are all transitive. Okay. So to those who didn't fully understand this one, so I'll give this one as your uh, self-study example or self-study assignment example. Okay. So I would like you to check each one of those arbitrary whether this one is really transitive or not. So if there is at least one, uh, let's say 2, 2, and then you have 2, 5, and then if we don't have that 2, 5, then that one is already a not transitive relation. Okay, but in here, everything is validated, wherein this one is really transitive example, your transitive relation. Right? So I hope you guys get the concept of a transitive relation. So let's now move on to the example number 2 on why this one is not a transitive relation. So as you can see right here, yeah. So we have this ordered pair. We have the BC and then CB. So BC and then CB. So we have the XY, we have the YZ. So again, for us to be able to see that this one is transitive, then we should have the XZ, wherein that XZ is BB. So the question here is, can you find this BB on this set relations?
Yes, sir.
Anong yes?
No, sir.
No, sir.
Joke lang.
Ikaw, Miss Maxine, nanonood ka yata ng ibang kwan, tapos mag-yes ka na lang pag nagtanong ako. Okay, so this one is no. So we cannot find BB on this relation. So that's why this one is not a transitive relation. All right? So Are we clear so far regarding with transitive relation?
Clear po.
All right, so how about the others?
Sir, question, sir.
Yes?
Sir, is it possible ba na kunwari, parang ito, ikaw compare sa nandito, sir?
Yes,
Paano ba?
yes,
Paano ko
yes.
to?
Like the 1, 4, and then 4, 4. Is that what you're asking?
Or, paano ko, sir, kung 44241? Parang ganun.
4, 4, 2, 4, 1. 4, 4, 2, 4, 1. Then we should have 4, 4. Ah, okay lang, yes.
Okay, sir. Thank you, sir.
Wherein you're going to have 4, 4, right? Which is this one. So vice versa. Kapag nauna naman to, then you need to have 1, 4, which is this one already. Alright, so any other concern or clarification?
Wala, sir.
Alright, so let's now move on to the next one. So we have here an example wherein consider the relation less than or equal to on the set n. So set n is a natural number. And then this one is an invisible x and then another invisible y. So x is less than or equal to y on the set n. All right, so my question here is, so what are the list of numbers wherein it's under natural numbers again? So what are those elements when we say natural numbers? Should we start with 0 or 1?
1,
1.
sir.
1, all right. So since this one is infinite, okay, so we will only take 3, okay, para mas mabilis. So 1, 2, 3. Okay. So this now is the limited natural number. So we only have 1, 2, 3. So the question here is the relation reflexive if we have this condition? So as you can see, sige. I'll leave the analysis part unto you guys. So is this reflexive or no?
Yes, sir.
Why?
Sir, since ang
Parang
element
sa
naman kasi is ano, sir, hindi siya sobra or magiging mas kulang sa ano. Ay, lagi siyang sosobra or mag-equal lang sa
Mhm.
x. Kaya parang imposibleng magkaroon ng value na less than.
All right. So as long as you have this equal sign, okay, that condition, then you're already good to go. Okay. So initially, of course, you're going to start with 1, 1, and then after 1, 1, 1, 2, 1, 3, and then of course the next one here is 2, 2, okay, which is now correct with the second one, and then for the 3, 3, so yeah, 3 is less than, yeah, that's the last one actually, 3, 3. You don't have 3, 4, or more. Okay, so as you can see, this one is a reflexive relation. So as long as you have this equal condition. All right, so how about the next one? Is the relation transitive? Mas maganda pala pag nilist na lang natin lahat. All right, so let's list all of the possible 1, 2, 3. So let's list all of the possible relations. So we have 1, 1, we have 1, 2, we have 1, 3, then we have 2, 2, and then 2, 3, and then the last one is 3, 3. All right, so the next question here is the relation transitive? So again, when we say transitive, if we have x, y, and we also have y, z, then we must have x, z. Okay, so I would like you guys to check all of our ordered pairs, so 1, 2, 3, 4, 5, 6 ordered pairs, and everything, and all possible angles. So is this transitive relation? So sorry for my drawing, not really handwritten, but my drawing using a mouse. So it's kind of ugly.
Yes.
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
All right. Okay. So I hope to those who have answered yes, really check this order first. Well, yeah. If you're really going to check it, then this one is really transitive. Okay. So I was about to read reflexive. So this one is a transitive relation. Okay. Another example here is consider the relation less than on the set n. Okay. So again, you will only take 1, 2, and 3. But this time, it's only less than, okay, not equal anymore. So since right here is the relation symmetric, so I will not list the elements anymore because this one is up to 4, okay, natural numbers, where in our example, we only have 3. So as against right here, we have 3, 4, okay, but we'll never be able to have a 4, 3, okay. So that is why this condition is, or this relation is not symmetric. Okay? Wherein, of course, if it's not symmetric, then this one is already anti-symmetric. Okay? So parang naulit lang to. Okay? Ang dalawang symmetric and then anti-symmetric. Supposedly, the question here is the relation anti-symmetric? Okay, not just symmetric. Okay? So there's a correction on this one. So did you guys get this one?
Mhm.
Yes.
Parang di ka sigurado ah. Anyway, so that is why I'll giving you guys 1 week to read, study, reanalyze, and etc. Okay, to prepare and then answer your activities, uh, your quizzes, and everything. Okay, so you have plenty of time to go back with our module. All right, so let's move on to the next one. We have here the order relations. So we actually have two category when it comes to order relations. We have the partial order and then the equivalence order. But for now, we'll focus on the partial order. Okay, so when we say partial order, this is just another properties wherein it's composing those three properties. We have the reflexive, the antisymmetric, and then the transitive. Okay, so to give you guys a real quick way of memorizing this one, how do we say that this relation is a partial order? So mostly, uh, you will say that it should be reflexive, it should be antisymmetric, and then transitive. Well, there is another way in memorizing this one. So as you can see, just take your first letter on each of those properties. So it will form an acronym RAT. Okay, wherein this one is a partial order. So if it's reflexive and if it's antisymmetric and then if it's transitive, then that one is already a partial order. But if there is at least one that is not fulfilled, like for example, transitive is a no-no on that relation, we only have RA, then that one is not a partial order. Okay. So for you to be able to say that that one is a partial order, it should have those three relations: the reflexive, antisymmetric, and then transitive. Right? So we have another order wherein it's called equivalence order. So it's EO. So it is the opposite of this one, but only one. Okay, only one properties. So as you can see, it's the same. It should be reflexive, but this time it should be symmetric. Okay, and then it still should be transitive. So for partial order, it should be RAT, and then for equivalence order, it should be RST, wherein this S is symmetric instead of anti-symmetric. All right. So are we clear so far regarding with partial order?
Clear po.
Yes, sir.
All right. So let's have an example. Hindi ko na mabura to kasi ito yung ginawin yata ni Mr. Labsa. Anyway, so it says here, prove that the relation R defined on this Z plus by x, y is an element of R. If x divides y, and then you will get a result of even, okay, is a partial order. So first, we have to list the elements of that Z. So again, what is Z plus?
Positive integers.
Positive integers. Okay, so again, we'll only take three elements. Okay, so 1, 2, and 3 only. Since we're limited of time. So it says here, this condition here is x divides y, and then we should get a result of even. Okay, for us to be able to say that this one is in relation. Okay, so what are those ordered pair wherein they are in relation with each other? So of course you will start with 1, 1. So is 1, 1 in relation with each other?
No, sir.
Why no?
Sir, kasi hindi even yung result.
Because it's not even. Okay, so that's one. That's one. That one is add. So 1 divided by 1 is equal to 1. How about 1, 2?
Yes, sir.
So yes, so 2 divided by 1 is equal to 2, which is even. How about 1, 3?
No.
No,
No,
also.
sir.
All right. How
No,
about 2, 1?
sir.
2, 1?
No.
2, 1 is no. Okay? So baliktarin nyo lang yun kasi y divided by x muna tayo. So 2, 1 is no. Okay? How about 2, 2?
No.
No,
No,
also.
sir.
2
No,
divided by
sir.
2 is equal to 1, which is add.
No.
How about 2, 3?
No.
No,
Wow.
sir.
How about 3, 1?
No.
No,
No,
sir.
3, 2.
No, sir.
No, sir.
No.
There's only one, which is 1, 2. Okay. So let's see. Is this one a partial order?
No.
So guys, is this a partial order?
No, sir.
No, sir.
I made a mistake. Okay. So I thought we can verify this one. Supposedly, this one is actually a partial order. Okay. But then again, I think it should be 1 to 4, not 1 to 3 only. Okay. So let's add 4 here. Okay. So let's go back to the making or creating the list of relations. So we'll add 4 here. So 1, 4 is that, yeah, is that, or are they in relation with each other? Is that even?
Yes. Yes, sir.
1, 4. Okay. What else did we miss? 2, 4. Yeah, 2, 4. 2, 4 is also is an relation with each other. How about 4, 2? 4, 2 is 1. Okay, so no. So I guess up to this number only. Really? 1, 2, 2, 4, 1, 4. But this one, so this one is not a partial order. Okay, so I guess this one is a mistake. Okay, so supposedly this one is having a 0 remainder. All right, so that we can include 1, 1, 2, 2, 3, 3, and then 4, 4. But in here, this one is only transitive. Okay, this one is not also, yeah, this one is anti-symmetric, but this one is not reflexive. Okay, so my bad regarding with this one. So this one should be a 0 remainder. Anyway, it's already in there. So this relation is not a partial order. Okay, not po. All right. So again, for us to be able to say that this one is a partial order, so it should be equal with RAT. Okay. So R is reflexive, A is antisymmetric, and then P is transitive. Wherein in this case, it is not reflexive anymore. And yes, it's antisymmetric, and then it's transitive, but there's one property that is missing. So this one is not a partial order. All right. So did you guys get a partial or the concept of a partial order?
Opo.
How about the others?
Yes, sir.
All right. So again, same idea, just like what we have on the past properties. It's just that for us to be able to say that this one is a partial order, should be reflexive, symmetric, and then transitive. And then this example is not a partial order, since supposedly this one is a zero remainder. Okay. All right. So here's your seat work number 3. So determine whether each relation defined on the set of past integers is reflexive, symmetric, antisymmetric, transitive, and or partial order. So in here, you have to list all of its validated properties. Wherein if it's reflexive, then you should list your reflexive. If it's symmetric, then list your symmetric. If it's antisymmetric, then list your antisymmetric. If it's transitive, list your transitive. And if ever it is reflexive, antisymmetric, and then transitive at the same time, then that one is already a partial order. Okay. So another thing, if that one is already symmetric, then there's no way that it is antisymmetric at the same time. Okay. So there should be only one answer regarding those two. Okay, because those two are completely different or opposite with each other. All right, and then of course you have 4 numbers, 5 points each. So a total of 20 points for the secret number 3. So are we clear so far regarding with secret number 3? No, guys? Or
Sir,
ina-analyze?
paano yung element na ano, sir? Ilalagay namin para sa x tsaka sa y.
Set of positive integers. All right, so
Sir,
limit
parang capture lang, sir.
it to 5, 1 to 5.
Okay. Thank you, sir.
So actually, pwede nyo i-limit hanggang sige, 1 to 5 na lang. 1 to 5 na lang para pare-paras sila. So 4 numbers. All right? So the next one here is order relations. So this one is actually similar with symmetric. So when say order relations, if we have x, y, or x is less than or equal to y, or y is equal to less than x, then x and y are comparable. But if we don't have either, let's say we don't have x less than equal to y, or we don't have y is equal to less than x, then that one is incomparable. So basically, if we have this condition, that one is comparable. Okay? But if you don't have that one, then that one is incomparable. So if every pair of elements in X is comparable, then R is a total order. So in here, you need to check each ordered pair. If we have this condition, then that one is, yes, partial order, but will it fall under the condition of total order? So it is another way of verification or validation. All right. So we don't have example for this one. So just basically apply this formula, right? And then we have here the inverse of relation, wherein basically if we have x, y, if you're going to inverse that one, we're going to have yx. So again, this one is super similar with symmetric, okay? So as you can see right here, this is the original set, and then this is the inverse set. So we have 2, 4, then we should have 4, 2. We have 2, 6, then we should have 6, 2. 3, 3, 3, 3 are still the same. 3, 6, we have 6, 3, and then 4, 4 still 4, 4. Okay, so you can disregard this one. So the point here is if we have x, y, we should have yx. All right. So this one is called the inverse of relation. So same with this example, we have AA, so AA, BC, we have CB, and then CB became BC, and then DB still DB. All right. So are we clear so far regarding with inverse of relation?
Yes, sir.
Yes, sir.
Yes, sir.
All right. So
Yes,
another
sir.
one. So when it comes to forming the diagram of inverse of relation, so just interchange your domain into range and then your range into your domain. So this is the original one. So we have here the domain of 1, 2, 3, and then the range of A, B, C, D. But in the inverse relation, so it's now the opposite. So we have the 1, 2, 3 for your range and then A, B, C, D for your uh, domain. Okay. And as you can see, it's just like flip, not actually flip. Anyway, so just plot this one, this A1, and then A2, and then B1, C2, and then B2 here. And then you will get this one. Okay, so this is the diagram of inverse and then the original one. All right, so since again we don't have enough time anymore, so we will just continue the rest on the part 3. All right, so goodbye and see you guys on